Okay, and we're back. So again, just like I was saying to my in-person class here, also, if anybody at home needs to contact me, please email me. Please send me a message if you need to, get any resources or anything, let me know. I can send anything your way. I talked about if you're quarantined for an exam, right? In this class? Yeah, I think I did. Just one more time, just for the folks at home. So if you are here on Thursday and Friday, you will take your exam on Thursday and Friday. If you are not here for any part of your exam on Thursday or Friday, then you will take that when you return to school in January. Okay. The only exception is to that is that, like, if you miss Thursday and have free time on Friday, I will let you take both parts on Friday. That's fine. I won't force you to do part one when you come back. You can do both parts on Friday if you miss on Thursday. That's not an ideal situation for anybody, but if you need to, you can, okay? But again, if you get quarantined or are out for any reason, remember that you will be taking your exam when you return in January. We are not doing exams at home. Well, at least the math classes are not. That's like we decided that as a math department. So any Algebra 1 student, if you get quarantined, you will be taking your exam in January when you return to school. But I can't remember what else I was going to say about that. Any questions about exam or anything? No? Okay, we've got problems numbers 33 to 58 to go over, so go ahead and get out your exam review. Remember, what you should be doing right now is going through each problem, correcting your work, figuring out what you did wrong. If you still don't understand what's on the board and you can't figure out where you made your mistakes, hey, Mr. Lavin, can you redo that one? Or if you really confused on it, you didn't have any clue what to do, hey, Mr. Lavin, can you go number 32? Yeah. Please ask questions. All right, so here we are, problem number 33. So again, if you're watching along at home, feel free to pause the video and do whatever you need to do. Write down any questions. Go on. Or do you have this? No, you didn't print it out or anything? Okay. So if you all see it, chapter 6 test. Yeah.
Question 35 doesn't matter what the B is. Like, can it be in front of 2.5?
Just make sure it's multiplied to 2.5. Yeah, that's fine. I mean, it just looks weird going the other way, but it's still the same thing. It's not actually so. What I cannot have for number 35 is this, where you don't write the f of v equals. Do we know why? Because within the problem I said, use function notation. So you've got to use function notation. Go ahead.
For 36, we have to put in order.
Say it again.
For 36, do we have to put like hidden order?
No, I just do that. And you don't have to double up. Remember, like there's 2 6s or something in the domain. You don't have to write both 6s. You don't have to write all of the terms there. You just write one of them. Because you're saying what values are in the domain. Well, 0, 4, and 6. All right, let's scroll down a little bit. Anybody still need 33 or 34? Up the top. Number 39, you're going to see a story there. That's just one example. I wonder what page is it?
We could always just simply go back to that video.
Oh, that's the same graph too and everything, right?
Yeah.
Water level, times. Tree looks pretty festive over there, doesn't it?
It does look pretty good. I like the school, the cube.
Yeah. Yeah. Anybody still need 35 or 36 up at the top? Okay, there's the rest of 39. So you can see your answer there. I had some questions on 38. Make sure that those are two separate problems, right? I say for f of x equal to 2x squared plus 5, find f of x when x equals -3, and then find x when it's x equals 5. I'm just saying do two different problems. Plug in -3, then plug in 5. That's really what I'm asking you to do there. Yeah.
When you're plugging it in, you have to put it with the f.
No, that's just the notation to use, but honestly, if you just wrote 23, I'd be okay. If you just wrote 55, I'd be good. What I like about that notation is that you see both what you plugged in and what you get out. You see input, you see output. You see an ordered pair, -3, 23, 5, 55. Anybody still need 37 or 38? Also, make sure for number 37, if you graphed it and you got something that looks like this, that means you didn't use parentheses. Okay? If you graphed it and you got something really funky where it turns downward instead of turning back upward, then you didn't use parentheses. Remember that this means that it's a parabola, a U shape.
So when you're plugging it in, you just put -2 parentheses the number.
You do this. Okay, let me show you. So if I want -2 parentheses -2 squared,
Right.
-3. Make sure the parenthesis goes in front of the squared.
And after.
Or just right here. Right? Just put the -2 in parentheses.
Okay.
Can you not see that?
No, I got glass. I got it. Thank you.
Is that better?
Yeah.
Can you see that?
Yeah, I get it.
Okay.
Thank you.
Maybe. That better?
It's close.
That's not as good as I'm using.
Thank you.
I mean, you could always make a neon pink to make it see it.
Usually that makes it work. There's 40 and 41. Now, number 40 and 41, remember that whenever I ask for the domain and range and I give you a table, you just list them off. But when I give you a graph for 40 and 41, you actually have to figure out, look left to right, look top to bottom, and use an inequality to write those out. Sure. Oh, I gotta do that. Number 40. Let me see. Oh, I don't have the original up here. Oh, maybe I do. Do I? Here. Number 1. Semester exam. Look, there's your exam. Practice exam. Yeah, here we go. Oh, not that. I want this. Oh, there it is. Okay, good. And we want, you said number 40? Yeah. Okay, so here's number 40. I want to start off by figuring out the domain and range, right? And then I'll tell whether it's a function or not. Well, the domain, remember, whenever you're given a table, you list it off. Whenever you're given a graph, you write it as an inequality. So for the domain, I go from here to here. Remember, domain is left to right. So where did I go? I went from -3 to +1. -3 to +1. Yeah, those are always less than symbols. Because you want to read it, you want to be able to read it like this. Like you want to be able to say x is less than or equal to 1, which is everything to the left of 1. And then flip it around the other way as well. x is greater than or equal to -3, so everything above -3. And then we do the same thing for the y values. Remember that the y values are bottom to top. So here to there. Okay, I go from -5 to +4. I'll write it so you can see it. So the range is -5 to +4. No problem. Questions about that? Okay, then we go back to the key. Okay, let's jump to here. Good, and yeah, this would take us through the end of chapter 5. I gotta be honest, there's a lot of questions in chapter 5 on the actual exam. Yeah. So remember that whenever I'm asked to find the intercepts, right, to find the intercepts in the graph, let me just bring it to a new page real quick. Oop, kind of cut off the 16 there. That's okay. There you go. Whenever I'm asked to find the intercepts, I would love it to be in standard form, which it is, x, y, number, right? So what I'm going to do there is then remove the y value, solve for x, remove the x value, solve for y. What do I mean by that? Well, I'm going to write it like that, and then say, okay, -2x is equal to -16. So x is +8. And then do that. I have 4y is equal to -16. Y is -4. Remember that means 8, 0, and then 0, -4. A lot of people have been trying to like put that as one coordinate, like 8, -4. And then where's your line, right? You don't, yeah, I don't know. So let's go ahead. What? Let's go ahead and graph it now. Let me get an actual graph here. Right there. And let's plot our points. 8, 0 is right here. 0, -4 is right here. And I'll stretch a line in between them. There we go. Make sense? Let's jump back. There is, let's scroll down here to 44, 45. Two different ways to solve 45. You can either put it into slope-intercept form or get your intercepts, then find the slope. Does anybody still need 44 up at the top? Let me scroll down a little bit. Yeah, David?
So
Yeah.
I
I tend to forget the negative when I do it that way.
Do it this way?
Yeah, like if I do it like that, then I tend to forget the negative when I give it like off by.
Yeah, and especially, I bet if it's multiple choice, the negative is one of the, you know, like the one without the negative, which is gonna be a different answer too. So you gotta be careful. Yeah, Rosalie?
We do 47.
37?
40.
Oh, 47, yeah. That's it. 6, 45? Or what? One, this says 2/6 and then 1/3. You can come sit right here if you want. Okay. A little bit closer to the action. Let's go over number 47 real quick. Number 47, the value of y varies directly with x, and y is 8 when x is 5. Determine the k, write the equation, and then find x when find y when x equals 14. All right, so what that means is that, remember that k is equal to always y divided by x. Oh, I didn't take attendance this period. Oh, it's Mr. Pilato. Okay. Mr. Pilato. I'm doing well. How are you doing? I do. Why? What's up? Yes. Okay. Yes. That's the way, I was gonna say, that's the way mine is. When we initially set it up a long time ago, we always put my exam as 0%. Because then it didn't affect anything, and then when I calculated in for just that time period, it worked. Like for the final grade. Well, neither does TAC, so whatever then. Yep, right. Okay. So k is equal to y over x. So that means my k value is actually equal to 8/5, right? 8/5, 8 over 5. So that means y equals 8/5 x. And then when I plug that in, I want to know when x is 14. So y is equal to 8/5 times 14. I gotta look at my key just to make sure this is right. Oh, that's because I said 1.6. I was gonna say I didn't see 8/5 over there. There it is, 1.6. So 22.4. So y is equal to 22.4 after I plugged it in. Does that make sense? That was in the problem. To find y when x is 14. Oh. You just read 11. You did 11. Here's the rest of. There's 48 and 49. Your answer for that. Did everything else?
Everything, I don't even know.
What's the direct variation?
Direct variation y equals kx, where it's just y is equal to a number times x. Right? So this is your direct variation. Y is equal to kx, where k is really your slope. So like y is equal to 3x is a direct variation, which k is 3. Y is equal to 1/2 x is a direct variation. K is equal to 1/2.
Anything times x.
Anything times x. Remember, there's no plus or minus going on with the direct variation. And remember, all direct variations have to run through 0, 0.
Oh, so it's not direct variation if there's no like plus 2 afterwards.
Exactly, yeah. Yeah, if there's any y-intercept, then it's not a direct relation. And then I gotta go over to the next page to go to 50, so. Okay, anybody still need 48 or 49? I still see some people right now. I'm gonna leave that there for a minute. Okay. Let's go to 50. There's 50, 51, and 52. Remember, 50 is the one where you have to solve for b. You plug in x and y, and then you find your b value. Number 51 is the where you do the slope on top of that. You find the slope, y minus y over x minus x. So the m turns out to be -3, and then you just pick one of the points. I picked 3, -2, and found the b value. Remember, the other option to doing this is using the point slope form. Like, for example, for number 50, you would write y plus 2 is equal to 4x minus 3. And then you would say y plus 2 is equal to 4x minus 12. So I subtract the 2, y is equal to 4x minus 14, which is the same thing. Over here, if I wanted to do that by point slope, I would write y plus 2 is equal to -3, x minus 3. Y plus 2 is equal to -3x plus 6. And then I subtract the 2, -3x. Whoa, that's not right. Why is that not right? What did I do wrong? Hold on a second. No. Well, I mean, do you want to?
Yeah.
Yeah? Okay, well, let's just go over it then. Okay, sure. So remember that this one is, given the 2 points, find the line between them. And put it into slope-intercept form. Okay, so remember, the first thing that I've got to do is find the slope. Because remember, if I want to put it into slope-intercept form, no matter how I want to do it, I've got to find my m value. Simple as that. So let's do that. Remember, m is y2 minus y1 over x2 minus x1, which means -8 minus a -2 divided by 5 minus 3. So that gives me a -8 plus 2, which is -6 over 2. So -3 is my slope. And then I've got to use one of the 2 points to find my b value. So I'm just going to do, I know we like to do the solve for b method, so I'm just going to do that one. So it's m is -3, and I'm going to use 0.3 comma -2. I just chose one. That doesn't really matter which one you choose. So remember that it's y is equal to mx plus b. So you plug in your x and your y and your m. -2, -3, 3, and then plus b. And then I solve for b. So -2 is equal to -9 plus b. Add the 9. 7 is b. And then we go back in. Remember that the final answer is m and b plugged in. -3x plus 7. That's a 7. Make sense?
And how were you getting a different answer using the point slope thing before?
I don't know. Let's not worry about that. We'll get the answer right. There's 52, 53, and 54. Probably some sort of time mistake that's good. Yeah, number 51 and 54 are identical. So the one that we just did on the board together is exactly like 54, just with different numbers. See, those are the ones you know. Like, would I really give you two of the same problem? Probably not. But if I do two of the same problem, you think it's going to be one of the ones I leave off? No. No. Am I going to ask you a problem like 51 or 54? I mean, it's on there twice. I mean, they read twice, so. I mean, take a hint.
I'm doing 53.
You want me to do 53? Yeah. 53 said graph the line with that slope and that point. Okay. So all I'm going to do is, there we go. All I'm going to do is plot the point first. So the point is 3, -7. 3, -7, right? And then I use the slope. Rise 2, run 3. Rise 2, run 3. Or I could go down to left 3. Remember, positive slope goes up and to the right. And all I'm asked to do is just graph the line. I'm not asked to graph the write the equation or anything. And so that's all I got there. Make sense? Yeah. It's one of those ones that's like, are you sure there's not more to do? You sure? We were at, yeah, here, 55 and 56. Yeah, John, sorry.
Over 56.
Yeah.
Thank you.
So everybody pay attention here. We're going to go over 56. I figured we would have to go over either 55 and 56 or 55 or 56. So I'm, oh my gosh, you scared me. That was a loud booming voice right there. You need me?
No, you're good.
You sure?
Well, I do, but I don't want to interrupt you reviewing.
I teach.
You want me to take over?
Baker, you want to do this one?
Yeah.
Seriously, you want to?
Yeah.
Baker's got
I
it.
might actually get entertained if Baker's doing it.
Go 56?
He's probably going to do it right. You can't see the board from back there, but
Yeah,
yeah,
it's top.
forgot his last.
Good work, Baker.
Really.
Well, he didn't get it right yet.
Yeah. You got to explain it as you go, too. You got to be Mr. Lambert. You good, Baker? Because this is a hard problem.
Say confidently, you got it.
I got it.
Okay, you got it.
Yeah.
I don't think I got it.
All right.
That was great.
Yeah.
Year.
The final.
Right.
Well, we got to like five.
Hey, the 55.
You know, it'd probably help if we started right or something.
There's no way that we
We
can
can't
mathematically.
even see a final.
Right equation.
There's no way.
You don't have the answer, do you?
No, we got it. We would have anything compared. We just have to know that.
Blaine.
Baker, tell us what you're doing.
Writing the equation currently.
There's no way around.
So, what's wrong?
First, you gotta put it into standard form. Okay? It sounds legit.
How do you do that?
Okay, you wanna get the y alone? So you're gonna do is you're gonna minus the 2x over on this side. Then you're gonna minus the 2x on this side.
Oh, God.
3y equals minus 2x minus 6. Okay?
Oh, my God.
You guys follow?
Yeah, I've got it.
Alright. Okay, you're gonna divide this by 3, get the y alone, divide by 3. Then you're gonna divide by 3. And then y equals negative 2/3 x minus 2. Okay?
So, the calculation at the end of the year is wrong? Like, is that what?
So it's not where you
In Venice saying you're wrong, so you're probably right. I think.
Definitely not wrong.
But nobody's putting exams in the course. You know what I
I'm
mean?
trying to think.
But it can, because so like it's half, so we do that calculation automatically, so like, let's just say you're gonna look at 90.
Yeah, I don't know.
Well, you wanna finish me off?
Get a 98, it's
I don't wanna
already.
waste my time
looking at your stupidity.
Which is not the right grade.
Yeah, that's the most important part.
You did okay.
Did you do it right?
Yeah.
The first part,
Did I
Come
do it
on,
right?
Baker.
actually, that's good, like halfway,
Baker's elaborate.
no problem.
Baker, solid effort.
Hey,
That's recorded too, by the way.
oh, let's go.
So, that's the slope, right? That's the old slope. What's the new slope then?
Oh, that's what I had to do, because it was perpendicular.
Positive 3/2. Right, remember it's opposite reciprocal. So we get the old slope by solving for y. So the new slope is opposite reciprocal. And at that point, I just go back and say, okay, well, if I wanted to run through 6 comma -1, I just got to do that process with 6 comma -1. So there's my x, there's my y. Y equals m x plus b. And I solve. -1 is equal to 18/2, which is 9. Subtract the 9. Y is equal to 3/2 x
I got the right answer.
minus 10.
I got the right answer. Will was trash talking to you the whole time?
No, you did
Will,
it wrong.
you are not
Before
doing
you
it right.
should. You only solve for the
Yeah, he said it.
old slope.
All right, any questions? Again, the difficult part about that one was the fact that there's so many layers, right? You had to find the slope, change the slope, use the point, make the new equation. All right, and then here is, okay, there's 55, 56. Let me go to 57 and 58. Remember, for 57 and 58, you just got to show the slopes. Just got to show what they are. Just got to count them off the graph. Count the rise and the run. Right? You don't have to do the slope formula. You don't have to do anything fancy there.
So you just need, for 57, you just have to show the lines connecting.
50, yeah, right. You have to show like where would the right angle be?
Okay.
B, you know, and then show AB and BC. Yeah, David? Yeah. Yeah, I know. I'm going to do it on the whiteboard here. Sorry for anybody playing along at home. I'm just going to do 55 on the whiteboard. Oh, that's not good.
Oh, I guess it's.
You got 55, right? What, you say 55?
Yeah.
Okay. 55 says, write an equation in slope-intercept form for line parallel to y is equal to 5x minus 2. Okay, now, the nice thing about this problem, as opposed to the one that Baker did, this one, you can already see the slope. The old slope is 5. Again, this is problem number 55. The old slope is 5. But if it's parallel, do I have to do anything to the slope? No. So the new slope is still 5. Do I care about this -2 at all? Is that -2 going to factor in at all? No. But we know that it wants to run through point 8 comma -2. Okay, so there's your x, there's your y. Y equals m x plus b. -2 is equal to, really, 40? These numbers really big? Okay. Plus b, subtract the 40, -42 is equal to my b value. So y is equal to 5x minus 42. Does that make sense, David?
Yeah.
Okay, you got about 10 minutes to work on problems numbers 59 to 64, if you'd like to. Remember, the entire thing has to be due tomorrow. And also remember that tomorrow, 59 to 64, we're gonna go over 59 to 64. With the remaining time, you are going to use studying for an exam. If you wanna make your note card, make your note card. If you want to study for math, study for math. If you wanna study for science, study for science. I don't care, but you cannot just sit there on your phone. You cannot sit and play on your computer. You have to be doing something productive. Is that clear? Yeah. Cool. I'm gonna stop the recording real quick.